This section of our linear equations chapter is on solving literal equations, and you'll see in just a minute what a literal equation is. So let's look at the steps first. Step 1, to solve a formula for a specified variable, which is what a literal equation is to clear the fractions by multiplying all terms by the LCD if there is a fraction. Second, you use the distributive property to remove parentheses if they appear. They don't always have the distributive property, but if you do, you do that next. Next, you simplify each side of the equation by combining like terms. This should sound familiar because these are the steps that we use to solve any equation. Then, this is where it's different. You get the specified variable on one side and everything else on the other side. And the last step is always to divide by the coefficient of the specified variable. I'm going to abbreviate. So it's very, very similar to solving the equations that you've done up to now, with a couple differences, and that is the number of variables that you have in it. So let's take a look at one. Example 1 is the equation for the volume of a rectangular solid. So it's volume equals length times width times height. So it's nothing but letters, no numbers in here. But we want to solve it for L. So that's called the specified variable. So what we do is we locate that specified variable. There it is. And you look at what's been done to it. Well, what's been done to it is it was multiplied by W and H. So we have to undo what was done to it. Now, if I go back to my steps, I see there's no fractions, there's no distributive property, I don't need to combine like terms. The specified variable already is on one side with everything else. So I just need to do this last step, which is to divide by the coefficient of the specified variable. So given that I want to keep the L, I want to divide by the stuff that is not L. So I divide both sides by WH. W over W is a 1. H over H is a 1. And I'm left with the L that I wanted. And I have L is equal to V over WH. So it's not like you're getting a solution, L equals 10 or L equals 7. It's just a matter of rearranging that equation. So we're going to do it again, same equation, V equals L WH, but this time we want to solve that for H. So H is our specified variable. Here it is. We need to undo what's been done to it, which means we need to undo the multiplication with division of LW on both sides. L over L makes a 1, W over W makes a 1. You're left with an H equals, and then you have this side, V over LW. So your answers are going to look different than what you're used to because you're not getting a number as your answer. All right, let's try one that's a little bit harder. Example 2 says, solve P equals 2L plus 2W for the W. So in this case, we're going to back up to step 4. We need to get the specified variable on one side and everything else on the other. Well, here is the specified variable. So the term that contains it is 2W. So we want that by itself. So I have to get rid of this stuff. Well, how did it get there? It was added to 2W. So we are going to subtract it from both sides to undo it. So on the left, I have P minus 2L, because those are not like terms, I can't combine them. These make a 0, and I'm left with 2W. So now I have isolated the term that contains the specified variable. The step that is last is to divide by the coefficient of the specified variable. So I divide both sides by 2. Now, pay attention to this step. I am allowed to cross cancel 2 over 2, making a 1. The reason is 2 was multiplied by W. So those are factors. You can cross cancel factors. I cannot cross cancel those 2's because this 2 is part of a unit numerator. So we end up with W equals P minus 2L over 2. And I know it's tempting because they're right there and it makes you want to do it. Don't do it. You can't cross cancel in that kind of situation. Now let's do the same one again. P equals 2L plus 2W, but let's solve it for L. Well, here's our specified variable. I need to get this away by subtracting a 2W. P minus 2W equals 2L, and now I divide by that coefficient. I cross cancel here, but I can't here, and I get L equals P minus 2W over 2. All right, let's try another one. Example 3, we have A equals P plus PRT. We want to solve it for this specified variable, and there it is. So first thing we need to do is to get everything away from it. Well, this has been added, so I'm going to subtract a P. That gives me A minus P on the left equals PRT. Now here is what I'm looking for, that R. So I'm going to divide, since it's all in one term and it's been isolated, I'm going to divide by the parts that are not R. So I'm dividing by the coefficient. So I have to do the same thing on the other side. P over P makes a 1, T over T makes a 1. You can do that even though they're separated, it's okay. And so you end up with R equals A minus P over PT. Again, I told you at the beginning, the answers are kind of odd looking. This next one, number 4, goes back to our first step where it says clear the fractions by multiplying all terms by the LCD. Well, I only have one fraction, and it's 1/3. So the LCD here is 3. Now you have to determine how many terms you have. So here's a term that gets multiplied by 3. And this side is all one term because it's all multiplied together. So I multiply it by 3, or 3 over 1. So on the left I have 3V. Those 3's cross cancel. That was the whole point. And I have a 1 times AH. And we are looking for A. There it is. There's no distributive property, no like terms to combine. It's already isolated. So all I have to do is divide by H. H over H makes a 1, and we get A equals 3V over H. So getting rid of the fraction first is critical in solving these. Here are 2 on your own, so I want you to try those. And then if you have questions, these are the ones you want to bring to class to ask about.